Good evening, guys. Once again, we are here again to continue our usual business, which is a question on the board to be solved. There's a question that says that an intercity shuttle travels between two cities, Amanfro and Kotoku, covering the first half of the distance at an average speed of 60 kilometers per hour, and the second half at an average speed of 90 kilometers per hour. The total distance between the two cities is 300 kilometers. Now, we have two questions here. A, which says that calculate for the entire journey the average speed of the shuttle. And B, if the speed of the shuttle in the first half of the journey is reduced to 50 kilometers per hour, determine its effect on the overall journey. So guys, that is our question for today. And let's see how best we can address this and then get our solution. Now, we are talking about a shuttle that travels between two cities. We can represent that on the diagram. So let's say A for Amanfro, let's say A for Amanfro, and then K will be for Kotoku. So we have a shuttle that travel all the way from Amanfro to, let's say, Kotoku. Now, in the first half of the journey, the speed of the shuttle was 60 kilometers per hour. And the second half of the journey, the speed was 90 kilometers per hour. What do we do here? Let's say that, okay, we have here as our midpoint. Let's all decide to call the middle of the journey as M, and agree that from the first point, Amanfro, where the shuttle moves, to the middle of the journey, we have 60 kilometers per hour. And then the remaining half of the journey, the speed of the shuttle was 90 kilometers per hour. Now, we are being told that the distance between the two cities is 300 kilometers. So it's 300 kilometers. So now let's move on. We will now have our problem nicely represented on the diagram. But the first question is asking us to calculate for the entire journey, which means that the shuttle moving from point A to point K, the average speed of the shuttle. And we all know that the average speed or the speed of a moving vehicle, or let's say a shuttle in our case, we call it S, is equal to the distance, which we usually represent as D, over the time taken, which is T. Now, we need to break the question into two equal parts so that we can easily get our answer for A. In the first half of the journey, we will tackle it differently. And in the second half of the journey, we will tackle it differently. So let's go with the first half. So in the first half of the journey, we have the speed of our shuttle, which moves at 60 kilometers per hour. And then the distance, which is D, we are being told is half of the entire journey, which is 1/2 times the entire distance, which is 300, which will give us 150 kilometers. Now, the time taken for this duration, we don't know. So that is something we can find now. Okay. Let's move our screen up a bit. So let's continue. So at this point, we just need to put our figures into our formula and then get our time for t. So we can now have our s, which is 60 kilometers per hour, equal the distance, which is 150 as shown, over time, which is t. So we can also agree that any number standing or any number standing alone can be over 1, so that we can easily cross multiply. So 60 times t equals 60t equals 150 times 1, which is 150. So in this case, we need to get our t. So what do? We easily divide both sides by 60 and divide this side by 60. Now we have our t equal to, so we have 150 over 60. So that will give you 2.5 hours. Your unit is hours. So that is our time for the initial journey. So it means that the shuttle moving from the first point and move through to the middle of the journey at a speed of 60 kilometers per hour, it uses 2.5 hours. In other words, that is 2.5 hours. Again, we will have to do the same procedure for the second part of the solution. So now, the second part says that after the train got to the middle of the journey, the distance remains was 150 because it has covered half of the journey, which is 150. Now the distance remaining is 150. And then when the distance remaining was 150, what did the shuttle do? The shuttle increased its speed to 90 kilometers per hour, but we still don't know the time it uses to cover the remaining part of the journey. So let's do that. Again, we know that our speed for the last part of the journey was 90 kilometers per hour. Our distance remains was 150 kilometers, and our time, which we don't know. So we can as well substitute these variables into our formula. So we have our s, which is our speed, b90 equals distance, which is 150 all over time, which is t. Let me take this screen a bit up. So again, we have this being over 1, you all know. So 90 times t, we are using cross multiplication. 90 times t will give you 90t equals 150 times 1, which is 150. So again, we divide here by 90, divide here by 90, and we have our t being equal to 150 over 90. What do we have there? 150 over 90. We have 1.667. So the nearest 3 does not place. And then the unit here is hours. We are dealing with hours. It's 90 kilometers per hour. So we are working in hours. So now we can realize two things. We can realize that the time taken to cover the first part of the journey is not the same as the time taken to cover the last of the journey. And the reason is simple. At the initial stage, the shuttle was moving at 60 kilometers per hour, which means that for every 1 hour, the shuttle was using 60 kilometers to cover that. Yes. And then the last part of the journey, the speed of the shuttle increased. And once the speed is increased, with the same distance, the time will be smaller, which is shown here. So what do we do here? We are now looking for the average speed of the entire journey. That is from point A to point K. But we now know that our total distance is still 300. So let's say total distance between the two cities is a, okay, let me put it here again. Total distance between two cities is at 300 kilometers. And then now we know that our time for the entire journey or two cities is now going to be our initial time covering point A to our middle of the journey, which is 2.5 hours, plus the remaining journey, which was covered with 1.667 hours. Don't forget the unit. Let me put a bracket here. Don't forget the unit. Okay, so we have two important parameters now. We have our distance, which is on top there, and we have our time, which is below there. So let's see, 2.5 of our time plus 1.667. That gives us 4.2. So our total time is 4.2 hours. Okay, so permit me, let me take the screen up again. Now let's move on. So now let's remind ourselves with our formula. The formula states that the speed is equal to the distance over the time. Now we are looking for the speed. We know our distance, which is 300 kilometers for the entire journey. We know our time now, which is 4.2 hours. So let's just put it into the formula and get our speed. So the average speed of the entire journey now becomes distance, which is 300 kilometers over time, which is 4.2. So remember our unit at the end. So 300 over 4.2. So that gives you 71.43. So 71.43, and this is speed. So that is kilometers per hour. So averagely for the entire journey, the shuttle was moving at 71.43 kilometers per hour. So that is our answer for A. That is our answer for A. So that is our answer for A. So let's move on. Let me take the screen up a bit. So let's check the second part of our question. So now we are good to go. We are now done with A, which is calculate for the entire journey the average speed of the shuttle. Yes. So what we did was that we found the time taken to cover from point A to M, which is our middle, and as well as the time taken to cover the remaining distance from point M to K. We added the time to get the total time taken, and then we know the total distance of the between the two cities. Then from our formula, speed equals distance over time, we got our average speed for the entire journey. So the second question is saying that if the speed of the shuttle in the first half of the journey is reduced to 50 kilometers per hour, determine its effect on the overall time. Now, let's look at it again. So we are being asked. Initially, the shuttle was moving at 60 kilometers per hour for the initial part of the journey. Now we are being asked that if this shuttle now decides to reduce its speed to 50 kilometers per hour in the first part of the journey, what effect will it have on the total time that will be spent on the journey? So we've been given an important parameter here again, which is speed, which is 50 kilometers per hour. Time we don't know. Distance we still know is the first part of the journey, which is 300 kilometers divided by 2, that is 150 kilometers. Sorry, 150 kilometers. Now let's look what time will going at a speed of 50 kilometers per hour give us using a distance of 150 kilometers. So we still have our formula being the same. Speed is equal to distance over time. We know our values, so let's go. We have our speed equal to distance, which is 150 over t. We don't know. We know our speed, which is 50. So we can as well put that in. 50 is equal to 150 over t. As we know, n number standing alone basically over 1. So we can do cross multiplication easily. So let's continue here. So we can do cross multiplication, and then by that we have 50k, 50t is equal to 150 times 1 is 150. Then, so to divide both sides by 50, so we can get our time. We have our time equals to 3 hours. So you can observe something very important. You realize that once the speed of the shuttle reduces, the time increases, which is a normal thing we all know. If, for instance, if you are walking fast, you spend less time, but when you walk slow, you spend more time. Okay, so that is basic as that. So we realize that in the first part of the journey, as the shuttle was moving at 60 kilometers per hour, it uses 2.5 hours, that is 2.5 hours. But as soon as it decides to slow down its speed to 50 km per hour, the time increases 3 hours, which means that additional 30 minutes has been added to the initial time. Yes, so let's see the overall time. Now, our new time for the first part of the journey has now become 3 hours. So let me get it here. Has now become 3 hours. So let's see, our initial time now is 3 hours. And then our time for the remaining part of the journey, you can call it T2, remaining part of the journey, and call the initial time as T1. So the remaining part of the journey, which we got, was 1.667 hours. So now let's see, to get our total time for the entire journey now, we now sum T1 plus T2, which is 3 hours plus 1.667. So in this case, we are getting a value of 4.667 hours. So let's compare this time with the initial figure, or with the initial time we got for the entire journey. Initially, our T1 for the entire journey when the train was moving at 60 km per hour was 2.5 kilometers, sorry, 2.5 hours rather. That was T1. Now, our T2 still remains 1.667 hours. And when we added them, we had 4.2, approximately 4.2 hours. We had 4.2 hours. So now, if you compare the two time ranges, you realize that when the shuttle decided to slow down for its first part of the journey from 60 kilometers to 50 kilometers per hour, the overall time increases to 4.66, as against the initial time when it was moving at 60 kilometers per hour for the initial part of the journey, is 4.2. So let's see what's the difference. What's the difference between the two? Let's take the new time for the overall journey, which is 4.667 minus 4.2. So let's see what we get here. So you get 0.467 hours, which is approximately 0.5 hours. And since we know 1 hour is equal to 30 minutes, so 0.5 hours is the same as, okay, well, we know 1 hour is equal to 60 minutes. And then let's see how we can get this in minutes. So 0.5 hours is like 30 minutes, that is half an hour. So we have 30 minutes. And this we have 0.5, sorry, we have 0.5 hours into bracket 30 minutes. Anyway, 30 minutes. So this tell us that the entire journey has an addition of 30 minutes, which means that as the train reduces its speed for the initial part of the journey, the effect on the overall time is that 30 more minutes has been added to the initial time, which was 4.2 hours. So making it a total of 4.667 hours. So basically it tells that once you slow down your speed with the same distance trying to be covered, remember you are going to increase your time. And once you increase your speed, you reduce your time. Thank you very much for your attention.